Thank you very much. Thank you for the gratulation. A bionic world in the year 2099. Now, what is bionic? If you study the feet of a gecko, and if you transfer the atomic principle of the adhering principle of the gecko into human technology, and for instance, if you design gloves to go like a gecko along the ceiling, like Spider-Man, then you are a bionic engineer. This is not science fiction here. It is really possible. The adhesive forces of a gecko feet are so large that it's possible to design such gloves for Spider-Man. Now, bionic in the year 2099. I know the view into the future is very dangerous. It's a risky attempt. And in the history, many people have made, famous people, big mistakes. For instance, the statement was given 1895, heavier than air-flying machines are impossible. This was Lord Kelvin who stated this. And I'm always astonished about this statement because every day I think birds, and birds are heavier than air-flying machines. They were circling around him. And so this is my intention now in this lecture here. The bionic futurist looks always to existing solutions, a bit more here in these directions, you will find in nature. The amazing results of biological evolution for the future designs. That's what the bionic futurist will do and what I will do now in this short lecture. Now, I start with bionic manufacturing in the year 2099. You may think, yes, manufacturing in nature, manufacturing of automobiles maybe happen in this way. The cars will grow inside a cabbage-like plant, and after the season, they will be harvested. No, of course, that is nonsense. I will cancel it, but I will say that I am convinced that in 2099, a new age of manufacturing will arise. At this time, in 2099, milling machines and drilling machines and turning machines, they are out. The crude metal cutting of today is out. In the end of the century, we will have smooth manufacturing by growing things inside a bionic breathing bath, like these gear wheels which grow inside this bath. Now, I do this forecast because I think that in the middle of this century, two new scientific disciplines will arise. One has a name, replionic. This is a science of self-reproducing structures. And the other science, auxonic, is a science of growing structures. Now, self-reproducing structures. The beginning to do this may be the creation of self-reproducing molecules. Like this, you have one molecule, and this molecule will make a copy of itself. Then you have two, and the two will produce then four molecules, and so on. And now, at the end of this development, maybe a silicon-based artificial life at the end of our century. And now back to the smooth mass fabrication of components, engineering components, in a bionic breathing bath. We start with a seat gear wheel, put it in, and out comes the mass fabricated gear wheels. Now this kind of manufacturing, of fabrication, has another big advantage, because you can do the following now. This is a normal fabrication of gear wheels, but now you can put into the bath a so-called scaling substance. This scaling substance works similar to a hormone in biology, and we all know that hormones sometimes will have the effect that we have dwarf growing, very small growing, and so after you have put in the scaling substance, you will get a very small gear wheel, maybe 1,000 times smaller than the original one, and this would be a very good method to design nano machines. In the year 2099, everybody has a three-dimensional printer on his desk, and here you will see the instructions for the Morph Jet 7 in 2099. The first step you have to do, instead of change the toner cassette, you put in a morphofluid. Next, instead of refill the printer with paper sheets, you put in a morphoderm. Then you select the product in the internet, in the wide world web. No, sorry, that's wrong. In 2099, the World Wide Web has died out. Now, at this time, we have the GNN, and the GNN is a global neural net, because all the computers in these times were neural computers and no more the computers working after the principle of John von Neumann. And finally, you take out the product, in this case, a purse, of course, without money. A next top seller in the year 2099, this is Brisopan, self-breathing solar paint. If you have a good illuminated wall at your house or at any other place, you buy this Brisopan paint, paint the wall, but you must not forget to fix 2 electrodes to the wall, because after you have finished the painting, you must give electricity into the electrodes, because then the formation of the intelligent paint will occur. You will see here a crystallization of the paint, and after this you drive with your, in this time here, 2-wheeled car, and you can harvest now the electricity with this very cheap Brisopan paint. Now, next chapter, future of functional and smart material. Now there's one material in our body which is really very intelligent. This is the bone. And if you have your leg broken, and the bone will come together, will grow together, but with the wrong orientation, then the following happened: a restructuring of the internal rod-like crystals will take place. For instance, if you have here such a vertical load of a part of the bone, then the crystals will, the rod-like crystals will orientate into the direction of the main stresses, and when the force will come in this direction, then it will turn by 90 degrees, and now this is a new orientation, so that the bone will have always maximum strength. And now what happened if you have such a material in 2099? The name is ossite, and Osseed, I repeat, has the feature of alignment of rod-like crystals in the direction of the stress trajectories. And now, if you have erected a new bridge in 2099, the following will happen. It's the first day, because the bridge has not the best structure. The first day, only pedestrians and bicycles are allowed to cross the bridge. After 20 days, now also automobiles are allowed to cross the bridge. 20 days later, lorries are allowed, and after 60 days, the bridge is open for each traffic, because then the self-structuring of the bridge has, under the given load, under the special load, has been finished. An advancement of Osseed in 2099, this is Novo Osseed. And Novo Osseed has the additional feature of self-healing. And you will see now, it is a very, very good material, for instance, for streets, for a road. A road in 2099 will, when the road will become damages, it will become overgrown. And the self-healing of Novo Osseed guarantees a road durability of 50 years or even more. I think that's very important, and not that every 5 years the street must be renewed. Now, traffic and mobility in 2099. Now, is it so that also at the end of the century, people will move to other places on our Earth, and they do not sit in a closed room and enjoying their vacation with virtual reality? No, they also will go to other places. And in 2099, the airliner, which is just hidden behind the cloud, has a following property: 80% less fuel consumption than today. And this is done due to so-called multi-winglets, the splitted wing ends of a bird, then by micro-longitudinal grooves. The model is a shark, and a compliant surface, that is, the model is a dolphin, and the so-called integral propulsion. The model is a flapping bird, but the airplane at the end of the century will not have flapping wings. I explain you this just now. First I go back. With the multi-winglets, it's possible to reduce the fuel consumption by 10%, because then you reduce the so-called induced drag, the drag which is produced due to the vortex which will always appear at the end of a wing. The micro-longitudinal grooves, they will damp the flickering movement of the turbulent flow, and so the fuel consumption will go by 20% down. Then the compliant surface, the model is a dolphin. This is a trick of in biology to remain laminar flow, and laminar flow has much less friction than the turbulent flow, and so you may reduce the fuel consumption by 20% again, and the integral propulsion by 30%. And now you may ask, what is the integral propulsion? And so I would like now to explain you how this works. Here you see an ordinary propeller. And then the propeller will produce a thrust. Then it will push the air from the left-hand side to the right-hand side, of course. Now you have a drag-producing system. In this case, the model is a sieve, but you can think all other drag-producing elements will have the same effect. The sieve, when it will be moved from right to left, then the fluid flow particle would follow the sieve. Now you have two systems. The first system, this is a normal system you will find always in aircraft engineering. You have the propeller and side by side the drag producing system, the sieve. And now if this system here will move from the right hand side to the left hand side, then at the position of the propeller you have a fluid flow in this direction, and where the sieve as a drag producing system was moved, the fluid flow will follow the sieve and going the drag producing system and will going from right to left. What does that mean? This is a propeller jet. This is a so-called sieve wake, and what you will see is much lost energy. And what happens now with this system, behind the drag producing system, the fluid flow will be decelerated, and then the propeller will accelerate the flow again, and so you will find that nothing happens after the flying object has crossed here, then there is no moved air. And this is a biological trick. All the biological thrust-producing systems will work in this way. This is a fish fin, this is a bird wing, always only to accelerate the fluid particles which has been decelerated before, and not to accelerate other fluid particles. This is much, much more better. Than maximum you can nearly serve 50% of energy. And here you see a negative example. When I go to Africa, then I always have to use the ferry from Gibraltar to Morocco, and some people say, oh, a very strong drive. It's a very, very bad drive, because what is it? It is a frost whipping system, and when you see here what is left behind the ship, that this is wasted energy, much wasted energy, and this is really an absurd propulsion. Aircraft of the future, and now I show you an aircraft of the future, will have a distributed thrust producing system. Always you have here acceleration of the decelerated flow particles here on the surface of the wing, and at the end, when you will do it in the right way, you have no moved air. So this was a bit long now, but I think it's always very interesting. Nobody knows this, that you can save much energy with a new kind of the arrangement of the thrust-producing system. Now I come to a problem. Many people come to my institute and they always ask me, in biology we have no waste, what can we do? Can we imitate the principles in biology? Now, look to this lady here. She is despairing because she didn't know in which container this the plastic bottle or the beer can has to be put in. And she remembers now that in biology all things are made of the same material, the proteins. For instance, the eye lens, an optical element, is made of a protein. Or the spider thread, that is a traction rope, is made of a protein. Or the nerve cell, an information processing element in biology, is made of a protein. And so in 2099, chemists and engineers developed the protein mimicry, which I gave the name promeme. And promeme is an imitation of what happens when in biology the proteins will be composed. You all know the Lego game, and in biology nearly a similar game is played. It is the biological Lego molecules are the well-known amino acids. We have 20 elements of them. Here of the Lego we have 24 elements, and we can build all possible things with this Lego, and this is the same here in biology. You can make nearly every form of a protein, and then every form has another function in biology with these 20 elements. And now, ProMeme is a similar experiment here. You see the bionic Lego molecules. In this kind only 7 of them, and here you see the ProMeme molecule. I must add here that scientists now are just trying to do this, to design Lego-like molecules, so that nearly all the materials then are composed of the same elementary molecules. And so you see what happens with in 2099, everything comes on the same heap, the decomposition of ProMeme products to their elementary components. Robobugs, roboflies, and cochloids. Here a small zoo of mini, micro, and nanorobots, and here a very important micro-robot, the cochloid. The cochloid is very small, solar-driven robot. It is like a snail-like micro-robot. The size may be like a 10-cent piece of euro. And you put the cochloid to the window, and the cochloid is then randomly moving, solar-driven, up and down, and cleaning the window, and at the end you have always a clean window. And through mass fabrication, I mentioned at the beginning of my lecture, the cochloids are very, very cheap, and if some of the cochloids will falling down, you must not look for it, you buy some new ones and put them to your window. The next we did speak about is, it is a micro air vehicle. In 2099, this is an advertisement of an all-purpose artificial dragonfly. Now, what can you do with such very small flying objects, artificial dragonflies? Now, for instance, you can make an environmental inspection with dragonflies moving inside a swarm, or you can make and you can examine a sewer, even if it has a small diameter, with such artificial dragonflies. Or, this is maybe very interesting, you see just an avalanche has gone down here, and there are some humans hidden under the snow masses. And now the artificial dragonflies form a so-called smart antenna to detect the avalanche victims. The smart antenna is an antenna which continuously adapts itself so that the sensitivity becomes a maximum. And now this swarm of dragonflies is able to detect the hidden humans, because if they are still alive, they have still a neural activity, and so they send out an electromagnetic wave, and the sensitivity of the smart antenna is so high that the antenna can detect the still living hidden humans. This is not new. In biology, the shark has such an electric sense, and the shark is able now to detect animals hidden under the sea ground, only due to the fact that the animals have a neural activity, breathing activity, and that they send out a electromagnetic field, and this is detected by the electric sense of the shark. Nanobiosensors and the supersense. Now in biology, for instance, for many insects, here for instance, the male of the silkworm moth, such an insect is able to detect one molecule. That is a special fishing net, the antenna of the male of the silkworm moth. And here I would like to explain you again, like I have done in the same way I've done with the integral propulsion, that chemists and engineers know how to build such a biosensor which is able to detect one molecule. You see here the signal molecule which has to be detected, and here the receptor. And now the signal molecule is connected with the receptor, with the result that a new molecule will appear which has the feature of a catalyzer. And this catalyzer, now this molecule is able to connect these two triangle molecules to a new molecule, for instance, 100 of them, and this new molecule, you will see here, is again a catalyzer. And this catalyzer now, we have 100 of them by this chemical process. This catalyzer now again will synthesize these two sphere-like molecules to a new molecule, which is again a catalyzer. And now you have 100 times 100, you have 10,000 molecules, and so on. That is a catalytic cascade, and I think so you see that is maybe that is in 20 years or 30 years that chemists and engineers are able to design such a high sensitive biosensor which is able to detect one molecule. And this is of course so very, very important for the future, because then you can detect, for instance, an explosive material somewhere. Or there's another example, you have here artificial dragonflies with a single molecule sensor. They will eliminate a potato beetle. Look to this place here. There is a potato beetle just eating the leaf of the potato plant, and then a typical leaf aroma will escape, will spread out in the atmosphere, and normally other potato beetles will be attracted by this leaf aroma. But now in my example here, the artificial dragonfly will be attracted and will do now singular elimination of the potato beetle. Now, bionic in civil engineering. Yes, when we think of building something, then we think of termites, and here you see the new is that in the future we have no more the top-down method with big cranes, but we have then the bottom-up method of building, and this is the robo-termite, just establishing the columns of a motorway bridge. Or you see here, this is again my photo here, it is a record of the tamarisk in the Sahara. The tamarisk is able to send the roots down to a depth of 60 meters, even if the ground is very, very hard. And so, at the end of the century, engineers are able to design so-called radiophores. Radiophores are artificial root mechanisms, and you see from Latin, radix root, and forare bore, and the radiophores in 2099 established then the foundations of the tower blocks of the future. You have not to pour concrete to big blocks, but I think that is much more effective and much cheaper than the big concrete blocks for building up a tower. So now I come to the end. Self-replicating vehicles in space mission. So now I come back to the beginning of my lecture, self-replicating systems. That is a topic, a subject of bionic, of course. And here, astro chickens. I don't know if you know this. This is an old idea of John von Neumann, and it was Freeman Dyson who has recreated this. the astro chickens. These are biologically inspired space vehicles which are able to reproduce themselves on planets with suitable resources. That means if we will send out life into the universe, and I think it's the next step of evolution, because the first big step was when the life comes out of the water and was spread out over the country, and now the next big step, I think, is that the life is sent into the universe. And if you will build one rocket or two rockets or 1,000 or 10,000, this is nothing. So this idea is much better. The astro chickens are sent into the universe and they roam about in the universe, and if one of them will find a planet with resources, then the astro chicken is going down, replicating itself, and then hundreds or thousands of them will be sent out again into the universe. That is the only method to expand life in the universe. And the last example, terraforming. Terraforming of the Venus in this case here. Now, you know, the Venus is extremely hot. Why? Because it is a very large greenhouse effect there, because 96.5% of the atmosphere is carbon dioxide. And now the idea is that a balloon is hovering in the Venus atmosphere, and that this balloon will spray out so-called EBOs. And EBOs are artificial balloon organisms. You see here such a self-reproducing balloon organism, and very important that more and more of these organisms will hover in the atmosphere of the Venus, where the temperature is not so very high. And now these balloon organisms are able to transform the carbon dioxide into a carbon complex and oxygen, and so one may hope that after 100 or 1,000 years, the atmosphere, the Venus, will become colder and colder, so that men can go down there and perhaps they can find breathing air. And this is the end of my lecture, and I thank you very much for your attention.